Okay, this lesson, 8-2, is called Which Method is Best? What we're going to be talking about here is now that we know how to solve quadratic equations in factoring, square root method, completing the square, quadratic formula, now that we know all of these, we want to be strategic about choosing the best option for the method that we're solving. I like factoring because it's fast. We can find a solution pretty quickly when it works. The problem with factoring is that we only get rational answers. Things like integers and fractions, so it works a lot of times. It's fast, it's good, but sometimes it doesn't work. So when you are deciding whether something factors, I would take a look at your A times C, see if you have two numbers whose product is A times C, but when you add them, you get B, the B value. So we'll check a few of those together. Square root method. This one is also really nice and handy, but it has a glaring sort of weakness. It can only solve equations that are missing their linear term. There we go. So if we had ax squared plus bx plus c equals 0, this whole thing, x to the first power, missing. If that's the case, then square root method is nice and easy. We get it into the form of x squared equals number, take the square root of both sides, and then we're good to go. So these both factoring and square root method are fast, but they're limited. We can't get all kinds of problems in this. Now, completing the square takes the square root method sort of up a notch. So let's find when is it advantageous to use completing the square. I would recommend that when you get a equaling 1, so if a is not 1, think about dividing every single term by whatever a is. If you get a equals 1 and b is even, then it's a good candidate, in my opinion, for completing the square. That's a pretty slick way to do it. You can still complete the square if b is odd. You're just going to have some fractions to deal with, and you need to be careful when you square those and how you treat them. Quadratic formula works for every single function. It always works. In my practice, I use quadratic formula as a last resort because it's, in my opinion, time-consuming and a little bit taxing. I generally need to pull out a calculator to make sure I've got the discriminant correct and working through all those kinds of things. So generally, I kind of hold off on that one as long as I can. Okay, on this notes worksheet, we have one of each type that we're going to practice. So let's take a look at this factoring example. It's already written in standard form, 3x squared minus 22x plus 7. So we have a, b, and c here. I've been teaching you that when you factor, you can look at a times c and put that up top. So that's 3 times 7. And then b, negative 22. And we're looking for two numbers who, when I multiply them together, I get 21. But when I add those numbers together, I get negative 22. This is a really good skill to practice, so I encourage you to pause here until you find those two numbers. Okay, since 21 and 22 are just one apart from each other, I recommend thinking about 21 and 1, but I need to add them to get negative 22, so I think they need to both be negative. That way, when I multiply, I get positive 21, but when I add them together, I get negative 22. Then we would divide by a. Our a value in this case is 3. So one of our factors is going to look like, it's going to have negative 1/3. And the other factor, let me simplify this, would look like x minus 7. If I were to write this in intercept form, it could look like that, right? So we want to see what value for x is going to make that factor equal 0. So what minus 7 equals 0? It's going to be 7. So one solution is 7. Even though 7 minus 1/3 doesn't equal 0, it doesn't matter, because if this equals 0, 3 times 0 times even a million or anything still equals 0. Okay, let's check this factor as well. What value for x is going to make that factor equal 0? And the answer there is positive 1/3. So there's our two solutions, 7 and 1/3. All right, let's try out the square roots example. This one is missing its linear term, so we don't have anything to the x power. To the first power, bx is missing, right? Not there at all. So we want to get this to the point where it looks like x squared equals number. So in the meantime, let's start by getting the term that has x squared alone. So we have negative 2x squared equals negative 144. To isolate x squared, we want to divide both sides by negative 2. So now we have x squared equals 72.